He works at Qualcomm, which is other from our sponsors. He has been a long contributor to our national group on C++. In fact, now that I remember, I met Raúl first time when I was giving one of my first trainings on C++ 11, when C++ 11 was modern. So, especially myself. Okay. Thank you very much, Raúl, for coming and for agreeing to give this talk under my request. Thank you.
Thank you. Thank you. So, okay, we are going to talk about CMake. I'm sorry about the C++ guys that can be here, but this is going to be about CMake, the compilation engine that we love to hate. So, I work at Qualcomm. We do things with 3D glasses and really cool stuff, and we are hiring. So if you are interested, please go to our booth. So that being said, what is the objective? So, okay, so this is a how-to guide on starting a project. I'm going to assume that you are like junior engineers that are learning to program in C++ and that you need to understand how to properly do, okay, that's, okay, and you want to learn how to use CMake. So this is a back to basics talk. So I am going to present some code in C++. So you are starting a project, code it in C++. You are using CMake. And we are going to be using Conan. So this talk was meant to span like 2 hours and a half. I think that I don't have so much time, only 1 hour and a half, I think. Well, yeah. So I don't going to tell you much about Conan, but take into account that if you were forbidden for any reason to use Conan, this talk would be quite differently. Okay, so take into account that I'm using Conan. I'm going to show you some Conan usage, but just very briefly. I'm also using Ninja. It doesn't matter that much to build the program, but yeah, I'm using Ninja because I like it. So I will not delve into the details of Conan, I'm sorry, but blame that guy. And also, because I don't have time, I will assume that you know something about CMake. It's not that much, and I think that you can really understand the slides, even if you don't know this. But I will assume that you know what are targets, what is executable, targeting libraries, find packages, and all of that. If not, I really think it's not going to be that much of a problem, but I hope you all know about this. So my overall goal is to update your CMake knowledge to 2025, because I have found that some people do things way differently than I think they should be doing, okay? Yes, great. Oh. Okay, big disclaimer. So these are my recommendations, okay? These are based on several sources, and by no means I am an expert on CMake. So I have a lot of experience with CMake, but take into account that this is a beginner-friendly guide. So I'm sure that several things that I'm going to tell you are not can be applied to your projects, because this is going to be like an entry-level project, the one that we are going to develop using CMake. And of course, your opinion may differ from mine. I think there is a word in English for that. It's, oh yeah, to be wrong. So yeah. Okay, first of all, before diving into CMake, I'm going to show you the full build process. I'm going to use what I call Conan-driven workflow. This is a 3-step process where we start executing Conan install. This Conan install is the command that will grab all the required libraries that we are going to use. It does so by inspecting the Conan file. It is also going to read what is called a Conan profile. This Conan profile is really important. I'm sorry I don't have time to explain all the details of that, but here is where you specify the compiler you want to use. That is why I'm calling this Conan-driven workflow, because it's Conan the one that is selecting the compiler, the main flags, and also the libraries that you are going to use. Okay, so the first step in our build process is this Conan install. This Conan install is going to create a CMake toolchain. I hope you all know what is a CMake toolchain. So here CMake is going to read the CMake toolchain in order to know which compiler we are using, with flags, and so on and so forth. Okay, so then the second step is the CMake configuration step. This CMake is going to read this CMake toolchain in order to know whatever Conan install has put in there. And it is also going to read the CMake list.txt file. That is going to be our main topic in the talk. Okay? This is going to create some Ninja files, and then the last step is the build itself, where Ninja reads those files and creates your binaries. Okay? So it's a 3-step process. So these 2 files belong to the project itself. This file, the profile, doesn't belong to the project itself, so I'm not going to talk about that. But take into account that this profile is really important because it's where you put all the knowledge about the compiler and the flags that you are using. Again, sorry for not having time to explain all of that. So let's go to the talk itself. Okay, so we are going to create a library. So this is going to be a full project. I'm calling it Live Awesome because, well, we are awesome, and because I also don't know how to spell in English. It is going to consist on just one library, Live Awesome, okay, with 2 public header files. Bar and full HPP, because I lack imagination. By the way, I don't know if you know Jason Turner. If you don't, please go to his YouTube channel because it's really amazing. Please don't use .h for C++ headers. Please don't do it. And I'm sorry for the previous talks, but yeah, some of you have done that. Okay, so I'm going to use namespace LiveAwesome because I'm creating the library LiveAwesome. So all my symbols are going to be in this namespace. And because of that, I want my end users to use includes in that way. So I want them to spell a prefix LiveAwesome. Okay, so that's my main goal. Also, I'm going to use a speedlog for implementation because I need to show something. And I will use gtest for the testing things. Okay, for testing things. Great. So, we are going to start with this folder structure where my repository is going to be called LiveAwesome under the source directory, and this is something that you should be doing. Under the source directory, you should put all your source files, and in this case, because I want my end users to be able to include LiveAwesome/bar HPP, I'm going to put not only the header files, but also the implementation files under this LiveAwesome subdirectory. Okay, and then we will take a look at the rest of the files. So let's start with our code. And yes, this is it. I know it probably has many defects, but it compiles, and I'm not interested in C++ code. So, yeah. So the important thing here, I think I don't know, is, okay, the important thing here is that these two functions are the ones that I want my end users to be using. Normally, I don't do this. I put my internal details in a different header file because this is like, but it helps me to explain later on something. So the main idea here is that these two functions are going to be used by my end users, but this one should be hidden. Okay, and then I also have this class foo here because, yeah. Okay, the implementation of this library doesn't, so the only thing important here is that I'm using speedlog because I want just to use one library. By the way, this speedlog library uses FMT under the hood, so it is not that easy to use it in your projects, and it is really easy if you are using Conan, as I'm doing. Okay, so use Conan. Okay, so speedlog and gtest. Okay, let's see the Conan file. So just two things about the Conan file. Again, I'm sorry, I don't have time to fully explain this. Just two things I want to comment on this file. First of all, I know that you can use a Conan file txt file that is easily readable, but I prefer to start with the Python one. As soon as your project grows, you are going to need this. So just start is as a Conan P. It doesn't. So just copy and paste this, and you are ready to go. Really, it's not that problem. And here I am putting. No. Okay. Hello. I don't know what is happening. See. Have I told you that I really don't like MacBooks? So, is that? Okay. Yeah, told me my boss that is not here, I hope. So, okay, so the other thing is that I have put these two lines, 9 and 10, in order to ask Conan to install these two libraries. So that's the thing, okay? Yeah. So let's start. This is the top level CMake list. All right. So the very first line in a top level CMake list should be this CMake minimum required. So this is telling CMake, hey, fail if the CMake version that you are using is less than this one. That is nice. But more importantly, this is telling newer versions of CMake. For example, if you are using CMake version 4, hey, behave as if you were version 335. That is really nice because it allows you to upgrade your CMake binary without needing to upgrade all your CMake list. So that should be the very first line that you are using, and it's very important to really specify the version that you are using for CMake. Okay, the second line, I'm talking about a small to medium-sized project. The second line should be the project line. If this was a really big project, then maybe it is okay to put several things under this, between these two lines, but try to put as the second line project. So what is this project function going to do? So first of all, it's going to set several defaults, like the name of your project, the versions, the language that you are using. But most importantly, this is the function that reads the tool change that Conan has created. So this line should be put as soon as possible in order to make CMake know which compiler and which flags are you using. Okay, so under the hood it does several things, but the important point is put it as soon as possible. This project line and this CMake minimum required is only needed in the top level CMake list. Okay? Then lines 4 and 5, this is the easiest way to install a package in CMake. So, because I'm using Conan, Conan is going to put a lot of information in the Conan toolchain, and it allows me to just put in this find package speedlock. It will create several targets for me to use in order to compile using this speedlock library. So it is as easy as I'm showing here. Normally, I don't put this find package in the top level CMake list. I put them near where I'm going to use it, but for this talk, I think it is easier to put them here. And yeah, so this is the way to use libraries in modern C++, in modern CMake. Use Conan and use CMake, modern CMake, okay? And the last line is, line number 7 is asking CMake, hey, go to the source subdirectory and read the CMake list. This is going to be the hardest slide of all the talk, so please bear with me. So first of all, here I want to create a library, okay? That's the main reason of the talk. So you should create a target, a CMake target. This target can be created with this line number 1 at library. So this is going to create a CMake target that represents the library you want to build. Okay, that's it. Line number 3 is going to tell CMake which files you need to compile in order to get your library. So in this case, bar CPP and foo CPP, easy. Okay. Because I'm using the source directory, I'm putting this CMake list in the source directory, I need to spell it like lib/bar CPP. Okay, but that doesn't matter. The private thing is important, so it is similar to the private of classes in C++. So users of my target, of my awesome target, don't need to know that I'm compiling these 2 files. So I'm putting it on their private because they shouldn't care about which files are used to compile my library. Again, copy and paste and modify it. Okay, the next line, it was a discovery to me. So I don't know how many of you have heard about these header file sets. But this is the modern way, the 2024 way of declaring which header files your library are going to use. So here we are telling the rest of the world which are our public header files. So you need, in order to do that, you need to create a public header file set, and you specify 2 things in line 12 and line 30. Line 12, you say, hey, in order to use this library, my users need to add to the include path this directory, the source directory. So because I want them to use #include libawesome/bar HPP, I need to add this include path, this source directory to the include paths. And this is the way of doing it, okay? And then I specify also in line 30 the list of public header files that my end users are allowed to use. This is important because CMake is able to install these files, and here we are telling CMake which files do we want to install in the installation step, okay? By the way, you can have as many target sources as you want. They stack on top of each other. So you can, for example, if you are on Windows and a file is only meant to be compiled under Windows, you can put an if I'm in Windows, target source, awesome, private, my Windows file.cpp. And it will stack on top of the others, okay? So that's really, really nice. Next line, 18. Target link libraries. So this is the way of telling CMake which files, which libraries I want to use in my implementation of the awesome library. So here I'm telling, hey, I need to use a speed log. Because I have put a find package before, and because Conan is providing me that find package, Conan is also creating this target. So this is the way to use Conan CMake in order to have your library. So just target link libraries and the target you want to use. Yes, I put it private because if you remember in the header files that are meant to be used by my end users, I'm not using anything related to the speed log. So speed log is an implementation detail. So I'm just using private. You can put public, and then your users will not only get your header files, but also the headers from speed log. And the last thing, this is really important, is to create an alias. For historical reasons, CMake is not going to complain if you make a mistake when spelling a library. So if you, instead of a speed log, : speed log, you just want to use a speed log without : and instead of speed log, just write a speed lag, CMake is not going to complain. So everything is going to work, it's going to seem to work, the compiler will work, and then the linker is going to fail. Most probably the linker or maybe some compilation is going to fail. And it is really hard to debug the problem. So try to use whenever you can this : thing. So instead of using regular target names, use the : And for that, you need that line 20. Here I'm creating an alias for my awesome library that is going to be called QC : awesome. I'm using the prefix QC. You can use the one you want, but in Qualcomm, we like to name us as QC because we are cool. So most probably you want to name it like awesome : awesome. It doesn't matter. The thing is that you use : That way, CMake will complain if you don't write it right. Now, a couple of don'ts. Please don't do this. I've seen this time after time. Again, this is my opinion. Okay, here we are setting a variable named target. By the way, CMake variables are awful, are terrible, so try not to use them. So here we are setting the name of our library as a variable and then using that library in several places. I know the reasons because people is doing this, but in 2025, I haven't found any valid reason to need to change the name of your target. Okay, so just don't do this. This is like creating a macro in C++ to name your variables. It doesn't make sense for me. So don't do this. Just put the name of your target and that's it. Yeah, that's, the rest is my opinion. This is actually spelled in the official CMake documentation. Don't use file glob. So file glob is, don't use it. That's the end of it. Don't use it. If one of your coworkers is so lazy that he doesn't want to spell the name of the file that, I don't know, has been working with the last couple of hours, I suggest to fire him. But this is not this is not the way to go. So yeah, it's really difficult for CMake to actually create good code for this. So just don't do it. Okay, it's in the official documentation. And last, do not set any compilation flag in your CMake leaks. Again, I am talking about medium or smaller projects. So if you have like a really big project, like a really big monorepo with hundreds and hundreds of targets, then maybe you are forced to do it. I will suggest not to do it. So don't try to use CMake to build hundreds of targets. I'm not looking at anyone. So it's a mess. But the point is, don't set any compilation flags. If you start putting compilation flags here, I don't know, how many compilers do you want to support? GCC, Silang, Microsoft, which versions? So it's a never-ending story of putting flags here. So don't put flags here, okay? So, yeah, so where do we put these compilation flags? Let me show you this README file. I like to put a README file with the compilation instructions. Here you see the three-step process. I'm calling Conan twice because I want him to compile not only the debug, but also the release versions. Here, this is the CMake configuration, more on that later, and here I'm calling Ninja, okay? So this is the three-step process that I have shown you before. This is the way to tell CMake in 2025, hey, read the CMake list in my directory, reuse the build directory that Conan install has created. Here we are telling Conan, I want to use Ninja, because I like it, the multi-config version with the Wuhan release. And this is the really important part. Here I'm telling, hey, use Conan tool change, because there you are going to find the compiler, the flags, and so on and so forth. So okay, and here we are putting our flags. I'm using this CMake flags debug and CMake flags release. This will be on top of the flags that Conan adds. So where do you put the compilation flags? You put it in the Conan profile, and if you want to add more flags, you put them here in a README file. Okay, and also, yeah, I like to do this to help IDEs to cope with me. Okay. So do I have any complaint? Yes, of course. README is not the best place to put our compilation flags. Okay, so let me talk about CMake presets, because I don't know how many people are using CMake presets. If you are not using them, please use them. They are like a game changer, I think. So let's talk about CMake presets. So CMake presets are stored typically in a CMake preset JSON file adjacent to the top-level CMake list. And they allow for the formal expression of configuration and build parameters. So this is a JSON file that can be read by IDEs. So your IDE should be able to read it. If that's not the case, then change IDE. Okay? Because, come on, this is 2025. The very good, but the best thing about CMake presets is that your end users can modify them without actually modifying CMake presets. So the idea here is that you commit this CMake presets JSON file to your repository, and you git ignore, if you are using Git, a file named CMake user preset JSON. Here is where your end users can add whatever they want. So, or you. So what I'm trying to explain is that CMake presets should hold the presets that are official for your library. So these are the official things that I'm compiling for. And if you want to test, I don't know, a new compiler or a new version of the compiler, or you want to add some flags, do it in the CMake user presets. So you can add things in the CMake user presets, inheriting from CMake presets, and here is where you should set the compilation flags. Okay, here and in the Conan profile that I don't have time to explain. Okay, so you can have one preset for each set of settings you want to support. So I want to compile with GCC 14, GCC 13, with debug enable for release, with Silang for Microsoft or Cloud. So just create as many presets as you want. So let's take a look at the, and then end users can add more. So that's the really big deal with CMake preset. So let's take a look at the main overall aspect of these CMake presets. It's a JSON file. The very first two lines should be the version of this JSON file. It happens that it should follow some schema, so just put the biggest number that your CMake allows you. And then you should also put this minimum required that should be the same as the one that you are putting in this top-level CMake list. Okay, and then you have different sections for your presets. There are presets for the configure steps. That's the one that we are going to see, for build presets, and for one thing that is called workflow presets. I'm going to present to you later on. So here is the look of our configure presets. So this is a list. I'm only showing you one preset, but you can have as many as you can. I think, so this is JSON objects. I think that the only required parameter is name. So the rest are not required, but most probably you want to put them. And there is like a one-to-one mapping with the CMake configuration line that we have seen before. So, for example, let's see. Okay, so for example, this /b is going to be spelled like binary dir. This toolchain file is going to be spelled like a toolchain file, and so on and so forth. I think it's really easy to follow the one-on-one mapping, okay? It's not that difficult. But we are not doing it in a README file. We are doing it in a proper way, that is the preset file. Okay, and here you see the compilation flags. So here is where you should put the compilation flags. You are not forcing your end users to use these compilation flags. Okay, build presets are for the build step. So this is nice. So you can ask, instead of calling yourself Ninja, you can ask CMake, hey, call Ninja for debug and for release. That's it. And then we have these workflow presets. These workflows are like microscripts. So what they are doing is, when I ask CMake to execute, I don't know, the first one, the QC debug, he is going to go step by step executing the things it found there. So for example, in line 27, he's going to execute the CMake configuration step. In line 28, it is going to be to build my debug version. So just by asking CMake, hey, execute workflow QC debug, I will get the configuration and also the compilation of my thing. So QC all, for example, just do one configuration and two builds. So this is really nice. My README file gets reduced to this. On that last line, CMake workflow preset QCO, just do this, configure, build for debug, and build for release. This should go directly to CI/CD because this is the thing you want to do. So that way you put how your users or your fellow programmers need to compile in the same language as your CI/CD. So that's the way to go, okay? Okay, next point. Again, JSON Turner, we should all be using visibility hidden by default. So this has to do with the symbols that we store in our libraries. So I want to create an add function, a foo class. I want those symbols to be usable, but if you remember this internal add function, I don't want my end users to be able to use it. The way to do it, as explained in this talk, is hide all symbols by default, and then unhide the ones you want your end users to use. And the way to do it in 2025 is, first of all, add these 3 lines to your top-level CMake list, copy and paste. I don't know why they have choose those variables name, but this is the way that you should do it. And now all the symbols that goes to your library are going to be hidden by default. So you cannot use anything that you have stored in your library. Great, so now I need to unhide all symbols. Okay, how do I do that? With a macro, because we all love macros. This macro is going, in my example, is called awesome export. And we need to use a macro because, as far as I know, this has not been standardized. So each compiler uses a different way of telling how to unhide members. And for that, we usually use a macro. And this macro, believe me, is not that easy to create. So I'm putting all the code for this macro in this library, libawesome/export.h, that is a C file, because it only declares this macro. I'm putting that in the add function and the subfunction because I want my end user to use those two functions, but I'm not putting that in the internal add function. So that way, even if they know that there is a function there, they are not going to be going to use it. And in the class, you have to put it that way. Okay, so how can I create this export.h file? With the help of CMake. So you just need to call this generate export header function. The generate export header function is going to create this libawesome/export.h class for you. Okay, so it's as easy as it is. In order to use this function on line 20, you need to go you need to include in line 1 this generate export header module. Again, doesn't matter, copy and paste. But there is one more thing that we should take care of, and that is what we do in line 21. My end users need to see this file. So I need to add to the header file set also this file that CMake is creating for us, this export.h function. Okay. This export.h function is not meant to be committed to your repository. So CMake is going to create that file in your build subdirectory, in your binary directory. Don't try to commit this file to the repository, it doesn't make sense, just use it the way you are seeing here. But that means that this file is going to be created in a different directory that is not our source directory. So we need to add also that directory to our header file set based dirs. And that is what line 24 does. So we are creating this new file and we are adding it to the file set headers and to our files. Okay? And really, that's it. Okay, another thing that I want to talk to you is about how to create a shared library. So again, don't do this in the CMake list files. Use your presets for that. Because this is a small project, and even for medium-sized one, you can use this build shared libs. This variable tells CMake to build all your libraries as shared libraries. I really don't want to force my end users to use either shared or static libraries. So try to do it this way. This is not possible if you have, I don't know, 100 targets in your repository, but I think that for small and medium-sized projects, this is a good idea. I'm not that sure about that, but yeah. So that's it. That's how you create a library. Okay, I haven't talked about unit tests. And this should be the first concern when you start a new project. Where do I put unit tests? How do I create unit tests? Okay, maybe this is contributed, but again, this is my opinion. I like to put my unit tests near my implementation file. And I like to name them as, for example, bar.test.cpp. So here is where I want to put my unit tests, because they are so near my implementation file. So I like to work with them as a as a set. But it is also important to know that I like to create 2 executables for them. So this bar test CPP is meant to create a bar test executable that when you execute them, it will execute all your unit tests of this file. Okay? So how do we do this? First of all, this is some implementation, doesn't matter at all. I'm using gtest, that's the only things that it's important here. Well, there is another point here. I'm not providing any main function. I'm just putting my unit test here. So where do I get my main function? We will discover now. So in order to create this unit test, these 2 new executables, I need to add 4 lines for each of them. First of all, I'm creating this new CMake target bar test that is of type executable. I'm adding the source files as before, and I'm telling him, hey, I want to link not only with the library that you are testing, but also with this CMake main. This CMake main is something that Conan is providing to us. It is a target that not only has all the gtest framework, but also has a main function that simply runs all the tests that you have. So that way, when I working with bar, I'm just executing this executable. I'm just compiling and linking this executable. This make it way faster to work with this. So I think I found this really, really helpful and a really good idea. The last line, line 35, is add test. So I want to register this test in CMake. That way I can ask CMake to execute all my tests, and this one is going to be executed. And the other 4 lines are the exact same thing, but for the other tests. So now, by the way, in order to use this add test, I need to include enable testing. So that should go to the top level file. Okay, so now what I can do is create a new set of presets. These are called test presets, where I'm asking CMake, hey, execute all the tests in debug mode, execute all the tests in release mode, and I'm going to add to the QC all workflow these last 2 lines, line 51 and 52, that when I call the workflow preset QC all, I'm going to compile, I'm going to first configure, then compile for debug, compile for release, and then execute all my unit tests in debug mode and all my unit tests in release mode. So it's directly to CI/CD. Okay, so I found this really, really, really nice. Next, integration test. So what about integration test? So I don't have any strong opinion about integration test. I just create a directory, tests, and I put whatever I want there. Okay? So if you like to have like integration test, you can create a subdirectory under test. If you want to have end-to-end test, create an end-to-end test, or put all in the same directory, do whatever you want. I don't have any strong opinion about them. But what you should do, of course, is add this directory. And in this example, I not only going to add this directory, but also the integration and end-to-end directories. And for each test that you want to create, you just copy the same 4 lines as before. Okay, this tends to be more complex because normally you use a lot of libraries or whatever, but for this example, this just works. So just copy the same 4 files. Now, when you execute your workflow as before, you are going to see not only your unit test, but also all the integration and end-to-end test. The idea here is that I'm keeping my CMake list very small, very easy to understand. So that is the thing that you should try. Okay? And last, because I don't know how many more time do I have, Yeah, okay. So maybe we can talk about another thing. So this CMake install. So, okay, I have created my code, I have created my unit tests, my integration tests, end-to-end tests, and so on and so forth. So far, so good. I have created my CMake presets, so I can not only compile in an official way, but also test several things without disrupting the code. Now I want to have a CMake install. This is especially important if you are using Conan, because it is, if you provide a way of installing your library, in this case, you can easily create a recipe for Conan in order for this library to be used elsewhere. Okay? So the folder structure is the same, nothing new here. But in the top level directory, I'm adding this module, this GNU installers. So it turns out that in order to instruct CMake on how to install things, you need to set a lot of variables. Instead of that, you can use this standard, this GNU. By the way, even it is called GNU, it is just the standard they are using. It is going to work for Windows, for Linux, and so on and so forth. So this is like a standard way of specifying which subdirectories you want your installation to create. So in that way, your library is going to reside in a lib subdirectory, your include files in an include subdirectory, and so on and so forth. Okay, so just include that on the top level file, and then you can go to each target that you want to be installed, in our case, just the awesome library, and put this install targets line. In this install target line, you should name the target that you want to be installed. And here you can use alias. I think this is a bug in CMake. And you also need to specify that I want the header file set to be installed. With just these two lines and calling CMake install this way, when you install, you configure, build, etc. And when you install, then you got that nicely set up, where you have an includes directory with your library, and in a lib directory, and your header files in their common way. So this is it. So it's as easy as this is, okay? So main takeaways. Use Conan, okay? Use Conan. I don't have anything more to add. Use Conan, because it's going to be really helpful. It's going so you are going to be able to use third-party libraries as easy as I have shown you. Just put a line, a fine package in your CMake list, requires in the Conan file, and that's all. Use Conan to get dependencies, but also take into account that it is Conan the one who is providing the compiler and the compilation flags. Let CMake list text as clean as possible. Refrain yourself of putting anything here. So only use targets. Do not set any compilation flags. Do not force any type of target or whatever. I know that you have an obviously correct way of doing things, but your end users may have a different opinion. So try not to put anything in the CMake list, because there is no way for your end users or for the users of your libraries or somebody that want to compile your library to modify that, okay? Instead, use CMake presets, okay? So if I have time, I don't know, okay? Then, before going out, how do I create a CMake executable? Because I have been talking about how to create a library. So what about if my project is about an executable? So it turns out that it is almost the same. You need to create a library in order to create unit tests. That library is not going to be installed, but that's the only difference. So as you can see here, I'm just adding, I'm just adding this awesome directory Now it will have a main CPP function where I put the main stuff, but I want all my classes to be unit testable and so on and so forth. So you should have your library as shown before. I have changed names and things, but I think it doesn't matter. The main important thing here is that I'm creating this awesome executable as before. So it is just as before, okay? But we need to install an executable instead of a library. And turns out that that is not as easy as it seems. Because for an executable, I want to install my executable, but also any required libraries. In particular, the libraries that I have grabbed from Conan. And I'm sorry, this is the way it is in CMake. Let me try to, okay. So I'm telling CMake, hey, I want to install my awesome executable, but also my library. This is needed in the case your end users want to install Leaf Awesome as a shared library. It is not going to hard if it's an static library because it's not going to be installed. And then I want to install this runtime dependency set that is the way to tell CMake, I not only want my executable, but also required libraries by my executable. So you should create a runtime dependency set with this line 8 and use it here. In this line 8, I'm creating these awesome deps, and I'm just copy pasting what Conan documentation has because I barely understand that. So the only thing that it's worth mentioning is that I'm using this Conan runtime libdirs. This is provided by the Conan toolchain. Okay, so here we are telling, hey, look for all required libraries under these directories that Conan is telling us, and exclude all these things that somehow are not needed, okay? Oh, yeah. So when I execute the installation step, I will get this nice layout. So my executable is going to be here, and my libraries are going to be here. Look that not only speedlog has been installed, but also FMT, because speedlog requires FMT. So this is really, really, really nice, and it's as easy as I have shown you. Okay. By the way, CMake take the precaution to modify the runtime path in order to be able to execute this executable wherever you put it. So that way I can go here and execute it and it will work. Okay, so this is really nice. I think this is the way we should go in 2025 for CMake. So thank you very much.
Thank you, Raúl. Questions?
Hi, thank you for your talk. This is just like asking for your opinion in one regard. In these examples, we mostly work with where the source files are in a single directory. Like or your CVPs and your .h are in the same directory. Imagine that I have too many files and I start putting like another level of nesting.
Okay, that's okay. Yep.
What would your recommendation be of like how to build the library now? Should I just have like a single CMake source in the top directory and then just point to the subdirectories, or each directory having their own CMake list file?
I usually prefer to have just one CMake list and not spreading my CMake code all over several directories. But that has a limit. So I don't know how many files are you thinking of. If you are thinking about, I don't know, 100 files, that's not the way to go. Here I'm assuming that all of you are juniors engineers that are starting to work with CMake. If that's not the case, then we are talking about way different topics. I probably will try to put all the logic in the top level, in the source CMake list. Even though I will spread the CPP implementation files all over the place. But that has a limit. So I'm sorry, I don't have a clear answer about that. So I don't know, maybe you need to split your library in several pieces. So I don't know, it depends on the case. Depends. Yeah.
I have one observation and one request.
Oh, wow.
The observation is Pragma once is not standard C++.
I put there.
And the request is I have the title for your talk for next year.
Conan.
Which, no,
Okay.
it's going to be the modules version of this talk.
Yeah. Thanks for that, because I haven't talked about modules. I don't think that in 2025 is that easy to use it. I have used them, but okay.
You have your homework. You have your homework.
Yeah, but just let me to point something that I haven't explained. I'm also not showing you anything about sanitizers. You should add sanitizers all over the place. But again, I don't. I thought I was not going to have enough time. So, but you should add sanitizers. So. Yeah, maybe someday I will upload all my code to some repository, and then there you will see not only all of this, but also sanitizers and things like that, because that's really important. And also a modules version, but 2025, I don't know if we are ready for that.
Okay, thanks for the talk. I have a question. When you were talking about hiding symbols from your library, but then you want to test it. So how do you do that? Because it's not visible from the test.
Yes,
and
just don't test them.
Okay, but I need to test it. Yeah.
Why do you want to test something that is an implementation detail? So it's the same thing as C++. So if you think that function, that internal add function, is going to have some meaningful usage, you should put it unhidden. Okay, but this is like the way, hey, this is my idea, I'm going to implement it, I don't want anybody to use this. And yeah, maybe I want to test it, then probably you should unhid also that symbol. If you
This
want
is
to test
isomorphic to the case of a private member function. You don't test that thing.
But yeah, it's a very good question. It's a very good question because this function can be really big and you want to test it.
I was going to say that my interface is just a Python binding that loads something, you generate something in Python, you call your C++ library, and you do things inside. So I want to test those things inside from C++. But I don't,
Then most probably you need to, Interesting case. Okay.
I'd like to clarify, does it mean if you have these libraries, symbols not hidden, does it mean that they are not present in the debug symbols file and not possible to analyze crash dumps?
That's a great question. So if you hit the symbols, you are allowing your compiler to do several things with the symbols hidden, because suddenly your compiler is not required to even have those symbols in the library file. So let's go to the talk, to the Jason Turner talk. He explained this way better than I can explain it. But you can end up not even having those symbols in the library. Yeah.
So it's a bit more of an answer to him than a question. We are hiding symbols. We're not doing it exactly in the same way. It's a similar way. We're hiding them by visibility hidden. We're making them available through a linker script. But that shouldn't matter, right? That's kind of the same. It might depend on the compiler, but with the versions of Clang and GCC that we use, when you link a static library, the symbols are still present. It's when you link into a shared library that the symbols disappear. So in our case, we have a slightly more complex CMake that will always build a static library for the purpose of tests, and then optionally a shared library for the client, if that's what you want.
I suggest you that you listen to the Jason Turner talk, because you will discover that the compiler is able to optimize your code better if you hit symbols. That was unexpected for me. And because you are allowing him to do it. So, yeah, it's a really interesting topic. My main takeaway here is try to hide your symbols. Okay, if you are required to do several big unit tests and things like that, then okay, then it's not that easy. But yeah.
You basically said to put all the compile flags outside of CMake. But for example, normally libraries require, I don't know, a minimum standard, let's say C++ 14, 17, whatever. I normally enforce that on the target of the CMake. Where should I enforce that moving forward?
So what you can do is tell the compiler, what you can do is tell CMake, I require at least C++ 17. Okay, that's doable. I'm not showing you it here, but that's doable. What you should not say is, hey, I want this file to be compiled in C++ 17. Because then other users that want to use C++ 20, especially in Microsoft compilers, are going to have a hard time. So you can force CMake to actually build this and that target with at least C++ 17. It will fail if you don't pass the necessary flags to compile it in C++ 17, but that's all. I don't think it's a good idea to enforce a certain version.
Okay, thank you.
Yeah.
More questions?
Here and there. So this was going to be the nap talk. I mean, the sleeping talk. So many questions. So yeah.
Yeah, very short question. There is a Conan build command.
Yes.
And you don't use it. Is there any
so Conan build is for creating Conan packages, as far as I know. It should be someone that can explain it better. But I usually don't use it because, I just want Conan to install the necessary libraries, not to build a new recipe out of it. So if you are suggesting, hey, Raúl, you have forgotten to put the necessary instructions to create a Conan package, then yeah, that's true. It's on purpose. So I'm asking his help to answer that question. But okay. Okay.
I had a question about slide 11. If you could
11.
go to it.
This is Macintosh. Let me try. No. Which one?
11.
11. Where am I? Oh, wow. Here?
Yep, here.
Oh, yeah.
The previous
Here.
one. There we go.
Yeah.
So normally I've seen the sources added into the add library as like extra parameters instead of having the target sources.
I'm sorry, but
sorry.
I'm almost
Better?
deaf, so.
Is this better? Okay, so I've normally seen the sources added as part of the add library call, like extra parameters in the add library, instead of in the target sources.
Oh, yes, that's.
And then the headers in the add include directories or target include directories. Is this like a newer, better version, or is it equivalent?
This is a newer, better version.
Okay.
This is the 2025 way of doing it, as far as I know, because I'm not an expert. So this is the way to go if you, for example, want to try modules. So you know, this is what I have read, and I just only have read, like, I don't know, 100 books about this. So I'm not an expert, I'm sorry. But I'm pretty sure that this is the modern way of doing it.
It's a quick one. These file set headers, will it preserve the folder structure? I mean, if you had your headers divided per domain on folders, will it preserve on the install phase the folder structure?
It will preserve whatever you put on line 15 and 16. I mean, this libawesome/var HPP. So if you have it, then yes. Okay.
Any other question?
Over there.
Where? Oh, sorry.
Just because now that he said, the other guy said, now we don't need target include directories?
This is compiling. So, yeah.
Fair enough.
Yeah. So this base dirs is the one that is going to do the trick. So for me, it was a discovery that I have made like 2 months ago. So yeah, I think so.
Last question.
Yeah, maybe it's more a question for the guys in this side. Why don't we have a package manager in C++?
Great. That's absolutely great.
Because, well, I think there is somebody there that would give a better answer than me, but the thing is that we have multiple package managers, and this is outside the scope of the standard, and we don't want to spoil the business of package manager providers, but probably Diego can tell us.
We have package managers the same way we have build systems and compilers.
Yeah, but then, anyway, there are some specifications you are working on, the CPS or?
Tomorrow.
Okay, so
we have a talk about that.
This is a deferred answer. It's asynchronous, so you get the response tomorrow. Yeah. So come to Diego's talk tomorrow.
But it gives me the opportunity to tell you something. I haven't put anything about Conan in my CMake list. So if you want to change to BC package, you can do on your own presets. So this is one of those things that I really like about presets. Okay, so, but come on, use Conan.
Yeah, use Conan, but you know, we don't standardize IDEs and many other tools or sanitizers. So we have enough standardizing the language.
We are lazy. Yeah.
Coffee?
Yeah.
Te iba a decir,